Welcome to another session. So here we are going to study exercise 1.3. The first problem, prove that root 5 is irrational. So to prove this, we are using the theorem of contradiction. So by theorem of contradictions, we are going to assume the opposite way. That means we are going to assume root 5 is irrational numbers, right? So I written root 5 equals a by b. Here one important notes we should write that a and b are co-primes and b is not equal 0. This is very important one. You will get to know later why I written here. So it's very important one. That means you all know, I hope, what is co-primes are, right? So co-primes means a and b both are don't have any common factor, right? So it's the simplest form. Like I said in the previous video, one video I explained very well. So for example, if you take 2 by 3, so this is the simplest form. We cannot reduce it further. Instead, if we write 4 by 6, we can reduce it by 2. So in this case, 2 is a common factor, right, between these two numbers. So here the a by b should be 2 by 3, the simplest form, not 4 by 6. This is what co-primes are. 2 and 3 are co-primes, not 4 and 6. So a and b are co-primes, must be co-primes. So this is the one rule for if any number. This is the rule for theorem, right? So obviously b not equals 0. So let's try solving this. So by squaring both sides, we will get 5 square root 5 the whole square a square by b square. So in the next step, the 5 will come. So here's square root and 2 will cut. So here a square by b square, which implies 5b square equals a square. And so here from this step, a square can be divisible by 5. Right, obviously. Here if 5 comes this side, a square by 5. Yeah, able to divisible by 5. So since a also can be divisible by 5. Okay. So in the next step, if a is divisible by 5, then a can be multiple of 5, right? So some multiple of 5 means I write some value c, I take c. So a can be multiple of 5 since a can be divisible by 5. Okay, so here next step, I substitute a equals to 5c in any equations. I take this one. Let's substitute a equal to 5c in this equation and I get 5 equals to 5c square by whole divided by b square. Now I cut 5. So in the next step I have 1 here. So 1 here, so 1 equals here only 1 5 I cut it already. So 1 for 5 square 1 5 I cut it. So remaining 1 5 is remaining. So c square by b square. So in next step I write cross multiplications. I do the cross multiplication. So b square equals 5c square. So in this step I write 5. I take 5 to the other side. So 5. So b square by 5 equals c square. Hope you understand how to do this. So in this case, you can see from this equation, you can see b square is divisible by 5, right? Yeah. So then b is able to divisible by 5. Yes? So last time we spoken about this line, right? So finally we have b is divisible by 5 and a is divisible by 5. If a and b can be divisible by 5, then 5 must be the common factor between these two numbers. But we assumed already here in this area, we assumed already a and b are co-primes. So, but it's contradicts our prediction, our assumption, right? So, if co-primes means a and b or co-primes mean they should not have any common factor. But in our uh, in our calculation we find out b is divisible by 5 and k can be divisible by 5. So indirectly they have 5 as a common factor. So what we done here, so we just proved that our assumption is wrong. So once our assumption is wrong, our so we can indirectly prove that root 5 is not rational number. Okay, let me conclude our problem here. Since a and b are divisible by 5, then 5 is a common factor of a and b. So it contradicts our assumption that root 5 is rational. So our root 5 is irrational number. Hope you understand. Thank you.